The last thing I wanted to address is what happens if I have negative exponents. It's another thing where you can memorize the rules, but there is some sense behind the reason they work the way they do. And the thing you probably remember about negatives is when you have a negative exponent, you can always flip it and change it into a positive as a rule for how we define a negative exponent is. So what the rule says is that if I have a raised to a negative nth power, that's always equal to 1 divided by a to the n. Basically, or what was originally a regular exponential expression now changes to division 1 divided by the thing instead. Or if you have 1 divided by negative, it will flip back over into a non-fraction a to the n. And often we refer to this as a reciprocal, and that's another easy way to remember what a negative exponent does, is it reciprocates the value. It flips it across a fraction. So say you started with a whole number, it would change it into, like, let's just say we had 4 to the negative 1. That would change it to 1 over 4 to the 1, which is 1/4, and it would flip it over. Because, right, 4 started as whole, flipped over to 1/4. Or if you started with 1/4 and then you flipped it, it would flip back to 4. So the whole flipping behavior is what we call reciprocation, and that's really what the negative exponent does. And with number 3, very much the same. If we have a fraction raised to a negative power, it's equal to the fraction to the positive power, which again we call that a reciprocal when you flip the fraction over. And same as if you have 2 separate exponents which are negative, they will both flip each other over regardless. So before we get into looking at some examples, why is that the case? And I think one of the easiest ways to explain why this is true kind of fits in with the pattern aspect for when I was talking about, well, why is something to the 0 power? Why does that equal 1? Because that's a little bit of a strange one if you didn't really, think it through. But why does a negative exponent change to, why do we do this whole flipping reciprocal business? But basically, with the sense of the pattern, and thinking about, well, what's the difference between a positive and a negative exponent? Because negative exponents, like 5 to the negative 2, if you're just thinking about what the heck does that mean, it can sort of start to lose its value because, well, what does an exponent usually mean? It usually means I'm repeatedly multiplying. So one of the common errors that people will do here is they'll just say the answer is negative. But in fact, the answer to a negative exponent is never negative. That's only when you're multiplying 2 negative numbers together. Here we have a base of 5, and we're raising it to a negative 2 power. So the answer does not become negative, and well, this is kind of why. And really, if you think about what a negative number does, a negative always behaves opposite to positive numbers, right? Positives work in a very, are one direction of the number line. Negatives do the opposite thing. And if I think about, well, what an exponent usually does is it multiplies by more and more and more, the higher the number of them that I have. And what's the opposite of multiplication? And what cancels multiplication is always division. And if I think about, well, what does 5 to the minus 1 power mean? Instead of taking 1 times 5, it would be 1 divided by 5. And what I would end up with is a fraction 1 over 5. So the reason why negative exponents change into fractions is because that's the opposite of multiplication, division. Just like how adding and subtracting are opposites, when we're in the realm of multiplication, which is why 5 to the 0 was 1, is because we were in the multiplication universe, not adding and subtracting. The opposite, raising it to a negative power, is the opposite of a positive power, which is why it must be dividing instead. And if I was to think about what does 5 to the negative 2 represent, it means, well, 1 divided by 5 divided by another 5, repeated division, or 1 divided by 25, which again, if I were to apply that rule, this would state, well, 5 to the negative 2 is equal to 1 over 5 squared. That's literally what the rule said, is that I flip it and make it positive. But I think it's, a lot of students memorize that rule, which is can seem strange, but really I think about it more basically, is that if I have a negative exponent, that means division. So I have 1 over 5 squared, because that's, instead of repeatedly multiplying, it means repeatedly dividing. And same with 5 to the negative third. That would be 1 divided by 5. Or again, 1 over 5 cubed is easier just because that just means 1 divided by 5 divided by 5 divided by 5. They're all within the denominator. And the same thing applies to rules. All the other rules are based on the same exact logic. if a negative means division, well, if I have 1 divided by something that's divided, by the rule of fractions, I would be dividing by a division, so I would flip and multiply, and it would flip back to a normal non-fraction with a positive power. And if I was dividing by a fraction, it would flip and multiply, and that's why they flip, is because when we divide by something, if that's what happens, is it flips over, and when we already have fractions, it just flips back. And now looking at a few of the examples in the packet, say we wanted to do like x to the negative 8, y to the 5th. Well, any negative exponent, one of the common things we want to do is express it, our final answer, so that our final answer has no negative exponents within it. And usually in the instructions for the questions, it will specify what they want you to do or how they want you to simplify. But of course we can't combine these together because x and y are not the same. But we could say, well, y to the 5th, that's going to stay put because it's a positive exponent. But x to the minus 8th will flip down to the bottom because that's what negative exponent means, is divide by that number instead. And the last thing I wanted to mention about negative exponents is, like, if you were really, it's all consistent with the other rules. If we were thinking about the subtractive effect, let's say we used a to the m was 0. Notice that what we would get is exactly the same thing. And all of these rules, none of them are contrary to each other. They all make basic sense behind exponential notation, what it means, and they all work simultaneously. They should never contradict each other. So let's say I was trying to apply that rule, which is a to the m over a to the n is equal to a to the m minus n, which we already talked about, the subtractive effect. Well, let's say on top we had a 0 power. So let's say the m was 0. So, this is going to be 0. That's going to be 0 as well. 0, 0. Well, what that would leave me with is a to the 0 is 1 on top over a to the n. And on the other side, I would have a to the 0 minus n, a to the negative n. And notice that confirms exactly what I was talking about the whole flipping nature, is because dividing by an exponential expression changes to subtraction. That's an entirely different way you could verify why a negative exponent must behave the way that it does.